Hello guys, welcome. It's now only 1:30 a.m. actually, and I couldn't get any sleep. So I thought let's make a video. So this video is about data types and then the qualifiers about the data types, and then yeah, let's go. So you can see there are many different built-in data types. Let's put built-in data types, and the built-in data types are integer. The size of the integer depends actually on the compiler. So how does the compiler determine the size of an integer is assuming you have a 64-bit system, the size of the address that can hold in a single bus is 64. The size of the int will be 64. And if you have a 32-bit system, the size of int will be 32 because it's a third. You can store only 32-bit in an address bus. And if it's a 16-bit system, it's 16. So this one depends on the compiler. And there is something called short int. Short int is like by 2 of int. That's what we think actually. It depends on the compiler. So for 64-bit system it may be 32. For a 32-bit system it may be 16. But for a 16-bit system it will still be 16. So it depends on the compiler. And then long int. Long int. So if integer is 8-bit, then long int should be double of that one, right? That's what we think. It's not again. So for a 16-bit system, long int will be like 32-bit. For a 32-bit system, long int will be 64-bit. But if it is a 64-bit system, then long int will be 64. Who knows? So this one also depends on the compiler. And then what else we have? We have character. Character is just an 8-bit one. And then we have float. Float is a floating point arithmetic value, so it can store values like 12.3, 11.2, 0.0000, something like that. And the size of this one is 4-bit. And we have something called double. Double is double the size of float. That's what we think as well. So this one also can store values like 11.2, something like that, 0.1000.000. But this one also depends on the compiler. You may think like I'm saying everything depends on the compiler. Yeah, ultimately compiler is the one that is going to convert it to machine code. So everything depends on the compiler. And then if you want to really find out the size of the data types, so you can just use the size of operator. So let's say like I'm declaring a variable int x or maybe int size, and I want to store the size of the integer in this variable, so I can store like size of int. So here there are multiple things to take away. So one thing is like I'm declaring a variable. A variable is a kind of a label in an address that holds a particular value. It can be any type of values. The type of the value depends on the prefix that comes before the variable. So it's like so this variable name is size and it is of type integer. Integer means like it depends on the compiler how much bit it can store. And C is, I have not mentioned whether it is signed or unsigned. So signed means like it can store values like -1, 0, and then +1, and it can go on depending on the size. But an unsigned, the value starts with 0. So as we have wondered, we have seen in the previous example. So when we are returning -1, it rolls back to 255 because it wasn't signed in unsigned character, and then unsigned character cannot have negative values, and so it's rolled back. Same thing goes for this one. So here you can see I have declared a variable of type integer, and then I have assigned a value for it. So the value is like size of int. Size of is an operator. So operator in the sense like it is a built-in it is a built-in function. It's not actually a function. It's a built-in operator. So when the compiler sees this one, it knows what to do. So it will definitely calculate the value of this one and then put it in the size. So this is a compile time one, which means like when you actually compile it, the value of this one is calculated and then it will be assigned to the size. So it's not a runtime one. So there are two things in C programming. One is compile time and runtime. Compile time is like when you put gcc main.c, that is compile. Runtime means when you put /a.out, that is runtime. So this is actually computed during the compile time itself. So we can see gcc main.c, great, and then we can run it /a.out. But we have assigned the value to size, but we still don't know what is the value, right? So we can actually print. So print means how we have declared a function called main. Same thing, the C program itself has a function called the C library itself, or the C standard itself has a function. So when you say C standard, what happens is like when you compile the main function with the GCC actually links a library called libc. So the libc contains the function printf. So you can use this function. It's a free function, you don't have to define it. But in order to use this function, so we have to send two parameters. Parameter is the one that you want to send to the function if you want to do some kind of manipulation on it. So first is the formatter, and the next one is the value we have to pass it. So the formatter is always in double quotes. So inside the double quotes, if you want the integer to print, we put %d. If you want float to print, we put %f. If you want character, we put %c. So we put %d, and the variable you want to print is size. So how C works is like it first compiles and generates the object code, and then we can run the object code. So in order to compile, the C compiler, which is the GCC, need to know where it can find the printf function. So if we can see, I have not defined any printf function. So how does GCC know? So we have to tell the compiler that where it can find the printf function. So how C program works is like we can actually give a header file that contains the definition of the particular function for the GCC compiler to know that whatever it is looking, whatever label it is looking for, that is already defined in the set of headers. So for printf to be declared, like if you want to use printf, the header you want to include is stdio.h. So if you just expanded it, what it is like standard input output.h. So this is the syntax. You have to put /include and then double quotes and then the header file. So when you put this, the compiler does a step called pre-processing. So it will copy the entire file and then paste it here. So inside this header file, they have the declaration for printf function. So what the compiler will know is like, so it will come here, it will come to the main function, it will come to the printf. So it will check some function is used, and where it has been declared, it will check. Since we have replaced the entire file into this one by the preprocessor step, so it will directly find the printf is declared before the main function and just compiles. So when we run it, so after compiling, there is a step called linking. I forgot about that. So during linking, so we have only declared the printf function, but where is the definition for it? Definition means like what does the function do? How do we know it? That is actually in the libc.so library that is applied by the C compiler itself. So there are multiple steps called pre-processing, compiling, and then linking. Pre-processing replaces the header file. Compilation links all the labels, checks all the labels, and convert it to object code. And this one convert object code to executable. So during this process it will check for the print function, and then it will during this process, so it will replace the entire file with the contents of the stdio.h, and during this step it will go on, it will execute each one of this, it will check each one of the statement for syntax and everything, like what and all statements it has been used, and it will verify. So once it comes to this, it will find the declaration of this one in the replaced header file, and then during the linking it will find the definition for that one. So once everything is done, we will get an output called again a.out. So we can just run a.out, and you can see the size of the integer is 4. Likewise you can print for float, likewise you can print for double, you can check the size of character and everything. That's it guys.